In this video, we're going to determine the optimal solution of a transportation problem via modified distribution method or MODI. This method allows us to compute the improvement indices quickly for each unused cell without drawing all the closed path. If there is a negative improvement index, then only one stepping stone path must be found or must be determined. This is used in the same manner as before to obtain an improved solution. In applying this method, we begin with an initial solution. For this case, we're going to use the northwest corner method. And the total transportation cost using the northwest corner rule is the initial transportation cost is equal to 4,200. We now compute a value for each row. Call the values A1, A2, A3 pertaining to the rows, and values for B1, B2, and B3 pertaining to the columns in the transportation table. In general, we let A sub I equal to the value assigned for each row and B sub j value assigned for each of the columns. C sub ij is equal to the cost in a cell I sub j, or the cost of shipping from a source I to a destination j. For instance, this cell belongs to row 1, which is A1, and column 1, which is B1. Its corresponding C sub ij is 5. Another example, this cell belongs to A2 and B3, and its corresponding C sub ij is 3. Now, let's identify the used cells. The used cells are A1, A2, B2, B3, and C3. We're now going to compute the values for each A sub I and B sub j's using the relation A sub I plus B sub j is equal to C sub ij, starting by setting the value of A1 equal to 0. So for A1, its equation is equal to A1 plus B1 equal to 5. For A2, its equation is A2 plus B1 is equal to 8. For B2, it's A2 plus B2 is equal to 4. For B3, it's A3 plus B2 is equal to 7. For C3, it's A3 plus B3 is equal to 5. And then let's start with the value of A1 equal to 0. So if A1 is equal to 0, then B1 is equal to 5. Then if B1 is equal to 5, A2 is equal to 3. And on B2, if A2 is equal to 3, B2 is equal to 1. On B3, if B2 is equal to 1, then A3 is equal to 6. And if A3 is equal to 6, then B3 is equal to -1. After identifying the values of A sub i's and B sub j's, we're now going to calculate the improvement index for each of the unused cells using the equation improvement index is equal to C sub ij minus A sub I minus B sub j. And the unused cells are B1, C1, C2, and the equation for B1 is 4 minus A1 minus B2. The equation for C1 is 3 minus A1 minus B3. The equation for C2 is 3 minus A2 minus B3. The equation for A3 is 9 minus A3 minus B1. Substituting the values obtained from these calculations to this new set of equations will give us the value of the improvement index for each of the unused cells. For B1, A1 is equal to 0, B2 is equal to 1. Therefore, the value for B1 is equal to 4 minus 0 minus 1 equal to 3. The improvement index for C1, again, A1 is equal to 0, B3 is equal to -1. Therefore, 3 minus 0 minus -1 is positive 4. For C2, A2 is equal to 3, B3 is equal to -1. Therefore, this is equal to 3 minus 3 minus -1 is positive 1. And on A3, and on cell A3, the value of A3 is 6. The value of B1 is equal to 5. Therefore, this is equal to 9 minus 6 minus 5 is equal to -2. Since we have a negative improvement index, meaning we're going to have a redistribution on the cell A3, on the stepping stone loop of A3. The closed path for A3 is from A3 to A2 going to B2 to B3 back to A3. So the takers for this loop are A3 and B2, and the givers are A2 and B3. Among the givers, the lower value allocated is equal to 100, which will be redistributed along the loop. On A3, the sign is positive, so it will take 100 units. On A2, it's a negative, it will give away 100 units. So 200 minus 100 equal to, this is a taker, so it will take 100 units additional, so it will become 200 units. This is a giver, so it will give away 100, this will become 0. The new transportation tableau will look like this. And the process will repeat itself until such time all improvement index are positive. The used cells are A1, A2, A3, B2, and C3. The equation for A1 is A1 plus B1 equal to 5. Equation for A2, A2 plus B1 equals 8. Equation for A3, A3 plus B1 equals 9. The equation for B2 is A2 plus B2 equal to 4. And the equation for C3 is A3 plus B3 equal to 5. Again, we start with A1 equal to 0, therefore B1 is equal to 5. B1 is equal to 5, then A2 is equal to 3. B1 is equal to 5, then A3 is equal to 4. A2 is equal to 3, then B2 is equal to 1. A3 is equal to 4, then B3 is equal to 1. The used cells are B1, C1, C2, and B3. The equation for B1 is 4 minus A1 minus B2. And A1 is equal to 0, B2 is equal to 1. Therefore, the improvement index for B1 is equal to 3. The equation for C1 is 3 minus A1 minus B3. A1 is again equal to 0, B3 is equal to 1. Therefore, the improvement index for C1 is 3 minus 0 minus 1 equal to 2. The equation for C2 is 3 minus A2 minus B3. A2 is equal to 3, B3 is equal to 1. Therefore, the improvement index for C2 is 3 minus 3 minus 1 equal to 1. And the equation for B3 is 7 minus A3 minus B2. A3 is equal to 4, B2 is equal to 1, and the improvement index for B3 is 7 minus 4 minus 1 equal to 2. Since there's still a negative value on the improvement index, meaning this tableau is not yet the optimal solution, and there will be a redistribution on the cell C2, and the loop for C2 is so from C2 to C3 to A3 to A2 going back to C2. The takers are C2 and A3, and the givers are A2 and C3. The value to be redistributed is the quantity 100. So this is a taker, so we add 100 units. This is a giver, minus 100, this will become 100 units. This is a taker, plus 100 equal to 200. This is a giver, minus 100 will become 0. So our third transportation tableau is And the total cost for this tableau is equal to it's 3,900. And once again, we're going to check this if this tableau is already optimal. The used cells are A1, B2, C2, A3, and C3. The equation for A1 is A1 plus B1 equals 5. For B2, it's A2 plus B2 is equal to 4. For C2, A2 plus B3 is equal to 3. For A3 plus B1 is equal to 9. And for C3, A3 plus B3 is equal to 5. Again, letting A1 equal to 0, then B1 is equal to 5. And since B1 is equal to 5, using A3, then A3 is equal to 4. And on C3, A3 is equal to 4, therefore B3 is equal to 1. And on C2, B3 is equal to 1, then A2 is equal to 2. And then A2 is equal to 2, therefore B2 is also equal to 2. And the new cells are B1, C1, A2, and B3. The equation for B1 is 4 minus A1 minus B2. The equation for C1 is 3 minus A1 minus B3. The equation for A2 is 8 minus A2 minus B1. And the equation for B3 is 7 minus A3 minus B2. The improvement index for B1, since A1 is equal to 0 and B2 is equal to 2, improvement index of B1 is 4 minus 0 minus 2 equal to 2. For C1, the value of A1 is 0, the value of B3 is 1, and the improvement index of C1 is 3 minus 0 minus 1 equal to 2. For A2, the value of A2 is 2, the value of B1 is 5, therefore the improvement index of A2 is 8 minus 2 minus 5 is positive 1. And for B3, the value of A3 is 4, the value of B2 is 2, then the improvement index of B3, 7 minus 4 minus 2 is equal to positive 1. And since all the values of the improvement index are positive, again, it means that we can no longer improve this transportation tableau, which implies that this tableau is already optimal. And the lowest possible transportation cost is 3,900 with this allocation. Factory 1 will provide 100 units on warehouse A. Factory 2 will provide 200 units on factory B and 100 units on factory C. Factory 3 will provide 200 units on warehouse A, and finally factory 3 will also provide 100 units on warehouse C. And this ends the solution using MODI or modified distribution method.